Hi, my name is Ava Grace and welcome back to AGT STEM. Today we'll be talking about rocks, minerals, and fossils. And here are some of the ones that I've been studying. Geology describes the structure of Earth and beneath its surface and the process that has shaped the structure. It also provides tools to determine the relative and absolute ages of rocks found in a given location, and also to describe the chronicle of the geological history of the Earth as a whole, and also to demonstrate the age of the Earth. Geology provides the primary evidence for plate tectonics, the evolutionary history of life, and Earth's past climates. Now we're going to be looking at some of the ones that I've been studying. The first one we have is ammonite. Ammonites are fairly common and not as expensive compared to fossils such as dinosaur bones, but they're still pretty rare. Some ammonites can be fairly expensive depending on several factors. These factors include its specific species, what era or period it was from, where it was found, its size, and how intact it is. Okay, the next one is aragonite. Aragonite is a carbonate mineral, one of the three most common naturally occurring crystal forms of calcium carbonate. It is formed by biological and physical processes, including precipitation from marine and freshwater environments. And here I have an example of aragonite. Now the next one we have is aventurine. Aventurine is a form of quartz characterized by its translucency and the presence of cloudy material that give a shimmering or glistening effect, termed aventurine. And here I have some of those, and they are green. So if I were to name them, I would just name them green quartz. The next one I have is a desert rose, which is right here. That's what it looks like. The desert rose is an intricate rose-like formation of crystal clusters of gypsum or baryite, which include abundant of sand grains. The petals are crystals flattened on the C-axis, standing open in irradiating clusters. And here I have an example of it. And I feel like it looks more like a rose in the picture than it does in real life. The desert rose may also be known by the names sand rose, Sahara rose. Next ones we're going to be talking about is pink gastropod, which is right here, and the Sahara gastropod, which is right here. Pink or Sahara gastropod? Gastropods are definite univalves, fossil invertebrates. Gastropods are a class of shelled invertebrate mollusks that play an important role in the marine and terrestrial fossil record. Their name comes from the Greek word gastro, meaning stomach, and the Greek word pod, which means foot. So I don't have a pink gastroid, but I have a silver gastroid, and it looks like a snail shell. And the next one I'm going to be talking about is hematite. Large deposits of hematite are found in banded iron formations. Gray hematite is typically found in places that have still standing water or mineral hot springs, such as those at Yellowstone National Park in North America. The mineral can precipitate in the water and collect layers at the bottom of the lake, spring, or other standing water. Hematite can also occur in the absence of water, usually as the result of volcanic activity. And here I have a little example of hematite. The next one I'm going to be talking about is quartz, and I have 3 different kinds of quartz here. Which is just regular quartz, rose quartz, and blue quartz, all over here. Quartz is a hard crystalline material composed of silicon and oxygen atoms. The atoms are linked in a continuous framework of silicon oxygen tetrahedra, with each oxygen being shared between 2 tetrahedra, giving an overall chemical formula of SiO2. Quartz is the second most abundant material in Earth's continental crust, behind feldspar. There are many different varieties of quartz, several which are semi-precious gemstones, since antiquity varieties of quartz have been the most commonly used gems minerals in the making of jewelry and hardstone carving, especially in Eurasia. So the first kind of quartz I have is just regular quartz. I have 2 points and 1 little piece of quartz, and I really like these quartz points. They're really cool. And then the next one is rose quartz. It's pink, and I like it. And then blue quartz, which don't even look like quartz at all, since they're not seafood like the rest of them. Next, we're going to be doing jasper. Jasper. Aggregate of triangular quartz and or calcinite and other mineral phases. Jasper is a fake and is a pure variety of silica, usually red, yellow, brown, or green in color. Very rarely, but it can be. The common is red due to iron inclusions. Jasper breaks with a smooth surface and is used for ornamentation or as a gemstone. It can be highly polished and is used for items such as vases, seals, and snuff boxes. I have an example of red jasper right here. Okay, so the next one we're going to be doing is obsidian. And I have a picture of snowflake obsidian, which is one of the kinds of obsidian we have. Obsidian is produced when felsic lava extruded from a volcano cools rapidly with minimal crystal growth. It is commonly found within the margins of rhyodacite lava flows known as obsidian flows. These flows have a high content of silica, which gives them high viscosity. The high viscosity inhibits atomic diffusion through the lava, which inhibits nucleation of mineral crystals. Together with the rapid cooling, this results in natural glass forming in lava. Obsidian is hard, brittle, and amorphous. Therefore, it fractures with sharp edges. In the past, it was used to manufacture cutting and piercing tools. It has been used experimentally as surgical scalpel blades. And here I have regular obsidian, which looks pretty cool, and snowflake obsidian, which looks way cooler. Next, we're going to talk about geodes. The rock that you hit with a hammer, and there's crystals inside. Geodes are geological secondary formations within sedimentary and volcanic rocks. Geodes are hollow, vaguely spherical rocks, which means in which masses of mineral matter, which may include crystals, are included. And crystals are formed by the filling of vessels in volcanic and subvolcanic rocks by minerals deposited from hydrothermal fluids, or by the dissolution of syngenetic concretion and partial filling with sand or other materials precipitated from water, groundwater, or hydrothermal fluids. And I have some examples of geodes, and hopefully in some other video we will smash these open. Next, we're going to be talking about brachiopods. Brachiopods are a phylum of small marine shellfish, sometimes called lamp shells. They are not common today, but in the Paleozoic, they were one of the most common types. They lived near the shore, but now they have been pushed into deeper water by competition from viable mollusks. These are brachiopods, and They look kind of like a clam, but thicker. Okay, the next one we're going to be talking about is a clam. A clam is a common name for several kinds of viable mollusks. The word is often applied only to those that are edible and live as in fauna, spending most of their lives halfway buried in the sand at the seafloor or riverbeds. Clams have two shells of equal size connected by two adductor muscles and have a powerful burrowing foot. They live in freshwater and marine environments. In saltwater, they prefer to bury down into the mud. And I have an example of a clam. You can see it looks a lot like our last one, Ratchetfoot. Next one we're going to be talking about is tiger's eye. Tiger's eye is a chatoyant gemstone that is usually a metamorphic rock with a golden to red-brown color and a silky luster. As members of the quartz group, tiger's eye and the related blue-colored mineral hawk's eye give their silky lustrous appearance from the parallel ingrowth of quartz crystals. And here I have two examples of quartz eye. And they're very shiny in the light. Now we're going to be talking about a meteorite. A meteorite is a solid piece of debris from an object, such as a comet, asteroid, or meteorite that originates in outer space and survives its passage through the atmosphere and reaches it to the surface of a planet. When the original object enters the atmosphere, various factors such as friction, pressure, and chemical interactions with the atmosphere gases cause it to heat up and radiate energy. It then becomes a meteorite and forms a fireball, also known as a shooting star or a falling star. Once it settles on the larger body's surface, the meteor becomes a meteorite. Here I have a meteorite. And it looks like a piece of food. Okay, so the next one we have is pyrite. The mineral pyrite, or iron pyrite, also known as fool's gold, is an iron sulfide with the chemical formula FeS2. Pyrite is the most abundant sulfide mineral. Pyrite's metallic luster and pale brass yellow hue give it this superficial resemblance to gold, hence formerly nicknamed fool's gold. The color has also led to the nicknames brass, Brazil, and Brazil, primarily used to refer to pyrite found in coal. Here I have two pieces of pyrite. And this one right here looks like it might have gotten wet because it's kind of orange right from that spot. Like rust, maybe. But this is pyrite. Next one we're going to be doing is pumice. Pumice, called pumicite in its powdered or dust form, is a volcanic rock that consists entirely of vesicular, rough-textured volcanic glass, which may or may not contain crystals. It's typically light-colored. And it's typically light-colored. Did you know pumice floats on water? Well, is that true? I did not expect it to actually float on the water. Next. Thanks for watching UGT Sun. We'll see you next time.